Today we have Gary Shepson from Carl Zeiss Vision. He will be presenting on Zeiss customized lenses. Gary is a key account manager with Zeiss, and he works with independent laboratories. He has 34 years experience in industry. He is ABO certified and has 16 years with Zeiss. And here you go, Gary, and I'll turn the screen over to you if you're ready.
Okay, I'm ready.
All right. Go ahead.
I'm going to go ahead here. We are in today's training. We are going to understand the opportunity of customized lenses. We're going to introduce Carl Zeiss Vision customized lens products, and introduction to Zeiss Individual, and how to dispense. Let's get right into this. The opportunity is great. Customized lenses really are the future. We've been seeing it grow greatly in the past, and we expect it to grow greatly as we go forward. And now, for the first time, you can precisely personalize progressive lenses for each patient. Zeiss Individual is the banner product. But what we're finding with customization is that it really is the revolution of today. According to McKinsey, a book about 8 business technology trends to watch, is give the consumer the power and the tools to choose the color, fabric, taste, smell, size, content, or whatever of the product, and they will most likely be happier with their choices at a premium, of course. So it's really is the trend, and we've seen it in all different areas. As we see on this slide, 81% of customers are willing to pay for customized products. 41% have household incomes that are over $75,000. And so they're most likely to tell others about products and are interested in customized lenses. Soderbergh has invested significantly in equipment and in the space and everything necessary to have the capacity to be able to meet your needs for customized lenses. And they've also invested in Zeiss precise form technology. All of Zeiss customized lenses are backside produced. It's a real-time lens design engine. It's an incredibly meticulous process, and it's really free-form done right. The customized portfolio, all of the Zeiss, again, customized lenses are backside done, completely done on the backside. The front is just a single vision. And there are 2 different types. There's the HD or the 3D. That depends on the brand. 3 brands. Zeiss is the high-end. Sola would be value product. And AO is also value product. This chart shows, first of all, you see the 3 brands across the top, the Zeiss, the Sola, and the AO. And at the bottom here would be semi-finished or traditional progressives that you're familiar with most likely, the GT2 by Zeiss, GT2 Short by Zeiss, or under Sola, the Sola 1 Compact Ultra, or the AO Easy. So as we go into freeform, there's a first level of customization is what we call customized for prescription. And that would be the AO Easy HD, the Sola 1 HD, Compact Ultra HD, and the GT2 3D and GT2 Short 3D. This is customizing for prescription. It's the first level of customization. And let's look at what that really means. It means that it's precisely matched to what the actual patient's prescription is. So we're able to design the lens after knowing the patient's prescription and PD and fitting height. You can see here that in the past, when it's with traditional progressives, the designs are based on base curves, and so prescriptions are grouped together. So as you get more cylinder, or as you get farther from the center of that particular grouping of prescriptions, the less the patient is able to see well. And you can see on this chart that the green is where it's the perfect optimized design for that particular prescription. So with customization, we now can take that and turn every single prescription into a optimized lens design. Another way of looking at here is, you'll see on the left of this chart would be, this would be an example of a plano where the optical astigmatism is the perfect design. It's perfectly what the designers wanted for that prescription. Now as you see, if we go to a +1 sphere, it starts to change. +2 sphere, you start to see unwanted astigmatism up in the upper part. +3 starts to look really ugly. As you go out into the cylinder power, you can see how it changes on its axis, and out again in -2 cylinder. This would be a +3 -2. That would be done on a design that was based for plano. So you can see the difference that it can make when you want to optimize. We can take the design on the right and actually make it to the design on the left in that prescription. So that would be the first level of customization, customized for prescription. Now the next level is customized for frame shape, and that would mean a variable corridor. So under the Sola brand, we have the Sola HDV, and under the Zeiss brand, the Zeiss GT2 3DV. This would be customized for frame shape. Both of these are also customized for prescription, but then go to the next level. The next level gives you unlimited frame choices, and they're customized in customizable variable corridor in 0.1 millimeter steps. The fitting heights can be anywhere from 13 millimeters to 35 millimeters. At 13 millimeters, it gives you a 4 millimeters of full 100% add power. When we say up to 35 millimeters, we don't mean that at 35 millimeters we're pushing that add way down. What happens is after about 18 millimeters fitting height, the design would stay the same, but the add power as it goes all the way down to 35 millimeters will be complete, solid, and unchanging. So it's it gives for a great amount of reading area. So it expands the entire progressive design to balance all the viewing zones. So why do we want frame style customization or variable fitting height? It's because you can't get the perfect design when you are only working with either a standard progressive or a short corridor progressive. I think the easiest way to look at that is looking at these slides. This would be at a 16 millimeter fitting height, 14 millimeters, 12 millimeters, or 10 millimeters. I'm sorry, not fitting height, but corridor. And you can see on this slide that at the very left would be for a particular fitting height. You have a standard lens, which what would happen is it would cut off the reading area. Or in the middle, if you decide to use a short corridor, you end up with not the right design because you're narrowing the intermediate zone. But with a variable corridor, you can give the perfect balance, give them the right amount of reading without sacrificing intermediate. So that's the real advantage of a variable corridor. So that would be that level, the customized for frame shape. Then we look at the next level, which brings us to our banner product, which is Zeiss Individual. Zeiss Individual goes to the next level, having all the others, customized for prescription, customized for frame shape, but then also customized for fitting geometry. This would be the pantascopic tilt, the wrap of the frame, and the back vertex distance can be taken into account with this lens. So let's look at that. A monocular PD, panascopic tilt, back vertex distance, frame wrap angle. This is where we're able to give visual acuity exactly as it was prescribed, even though the frame is in an as-worn position, which is different than the way it was prescribed. If you look at a lens through a focimeter reading, you see that it's not exactly the way the eye actually looks through the lens. On the right, the picture on the right, you see the actual position of where the vertex distance, the tilt, everything like that has an effect on the way that the patient will see through those lenses. So let's take a look here at the effect of panoscopic tilt and face form wrap. On the left here you see that we've got 0 degrees and 0 degrees, and here is a lens with a +3 sphere that was designed particularly for that. So if we don't then take into account that and then start to change the panoscopic tilt to 5 degrees, face form to 5 degrees, you see that you're starting to cut into the reading area of that design on the right. Then we change to 10 degrees of panto, 10 degrees of face form, and you can see we're added unwanted astigmatism up in the upper part and the periphery, as well as really affecting the reading zone. Another 15 degrees, this gets even uglier. And then we go to 20 degrees, and you can see that it's really quite ugly, and it actually is reading at +4.04 -0.89, and this is supposed to be a +3. So just by changing face form and panoscopic tilt, you can see how that can affect the lens, and that makes for a limitation of traditional progressives. With individual, we are able to take the ideal performance and put that into a performance of a lens that is an as-worn technology. So we can take into account what that back vertex distance, panoscopic tilt, and wrap of the frame are, and get back to the ideal performance for that particular patient. So those are the 3 levels of lenses. We have the customized for prescription, customized for frame shape, and customized for fitting geometry. Zeiss Individual is the banner product as it goes to all of those levels. And then the final step there is that they can be personalized with engravings on the lens. There are initials that can be engraved on the lens. These initials are actually, it's that semi-visible engraving that is very difficult to see, as you know, in looking for the markings of a progressive. I usually say that I kind of play this down because the patient most likely will not be able to see these letters, but it is available to you if you want. Anywhere from 1 to 3 letters can be used for the patient. And so if ever you see looking for customized engraving, that's what it's calling for. So what you can tell your patients then is that these lenses are precisely personalized for them. The idea of precisely personalized has been floated before focus groups and has been the concept that the consumer saw as most understandable, that they really understood the idea of the customization, precisely personalized. The reason we call it customized instead of freeform also is that the consumer relates to that. They do not understand the concept of freeform, but they do understand a customized lens for them. So in getting started with fitting these progressive lenses, let's look at how to order, fit, and dispense, and then lens availability. First of all, for the fitting measurements, we have the monocular PD. This is something that you should be used to doing anyway for progressives. Monocular fitting height. We do want that to be monocular because if a patient's one eye is higher than the other, that will make a difference as long as the frame has been adjusted appropriately. The panoscopic angle, the back vertex distance, and the face form wrap. So for fitting measurements with Zeiss Individual, you either can go one of three ways for doing these fittings. You can either not put any measurements in and it will go to the default values. The actual population averages is what it would go for. So you're not actually taking advantage of the as-worn technology, but you don't have to with Zeiss Individual. You have manual fitting tools. You can see here there is a tool, I'm pointing here with the pointer, is used for measuring the panoscopic angle, and on the other side of this tool is a millimeter ruler that will be able to measure the back vertex distance. And we can have people teach you how to do that if you're unfamiliar with this tool. These tools are available through Soderbergh and are at no charge to you. Also the PD, very few people use a ruler anymore for PD. You probably have a pupillometer, probably using a PD ruler for fitting heights though. And then there's also a chart that can be used to measure the wrap of the frame just by lining up one lens on the main line, the main axis. Then the other lens will point to what degree of wrap that frame is. Very good tool, very accurate actually once you get used to using it. So those are the manual tools, but there also is a tool that you are able to purchase, which is the iTerminal by Zeiss. This tool would be able to do all the measurements for you much more accurately than possibly can be done with the manual tools. This will do the PD, fitting height, back vertex distance, wrap of the frame, and panoscopic angle. Plus it has the advantage of being able to, you can use it to show patients what they look like in their frames and show them what they look like with transitions or photo fusion lenses and with AR or without AR coatings. There are tools that are available to you through Soderbergh, also the fitting and dispensing guide that has all the information on how to fit and how to dispense the lenses, plus also information on each one of the measurements, the panoscopic angle, how to do that, how to do wrap, how to do the back vertex distance, and then also on this gives what the default values are. So if you don't specify which way, which measurement, if you don't specify a back vertex distance, don't specify a panoscopic angle or a wrap, it will go to the default measurements. Okay, it is also shipped with a RX form that gives what the actual prescription would be as you read it in a lensometer. It will be different from the prescription that the doctor actually prescribed. The reading will be different, but the reality of it, the whole idea is to get to that point of what the doctor prescribed. So even though it changes the prescription a little bit, it is actually the whole idea is to give the patient what they saw when they were behind the doctor's phoropter. And so this is a great tool that comes with the lens so that you are able to see how the lens should read in the lensometer. The material availability of these lenses is quite phenomenal. They're available in almost all materials. We have the CR39 in photo fusion, gray and brown, transitions, gray and brown, polarized gray and brown. There's a Trivex transitions. There's polycarbonate in photo fusion and transitions and new polar. There's high index 1.6, which is kind of hard to find these days, as 1.6 seems to be a material that is not used as much, and so more and more manufacturers are going away from that. 1.67 high index, and in photo fusion and transitions, both gray and brown. And then there's the poly transitions extra active and 167 transitions extra active. The lens design here that is comes from Germany is a 174 high index. It does take some time. We're saying about a month to get the lenses. But when you look at the range, you can see what an advantage this can be to people. The advantage of -20 to +16 out to a 6-cylinder. This is, there are not any tints with this, no transitions, no photoffusion, and drill mounts are not recommended. But you can imagine what someone with a -20 with a 6-cylinder would be able, the advantage that they would have with this lens. So it does take time, but it is worth it. We also have wraps that are available. These are just in the Zeiss products, the Zeiss Individual and the Zeiss GT2 3D and 3DV. The materials on that are CR and polycarbonate in all the different flavors, as you want to call it, range of -4 to +4, cylinder to -4. And, but it is necessary to specify wrap. So if you're asking for a Zeiss Individual PAL wrap, then you will get the wrap. And that is on pull-down menus of whatever program that you are using. If the wrap angle isn't specified, the default is 15 degrees, but up to 25 degree of wrap is available. So it's a really nice addition to the freeform or customized products that we have. We do have a little chart, kind of what I call a cheat sheet chart that is available that you can get from Soderbergh, and it is I keep updating it as we go along, and it shows, first of all the minimum fitting heights of each of the products. There are certain ones that are fixed corridors will have just one fitting height there. If they are customized for frame shape or a variable corridor, it will say 13 to 35. And then the rest shows all the materials that are available in each of the different lenses. And at the very bottom of the chart gives the defaults for the panoscopic tilt, wrap, and back vertex distance. One other thing, the lenses are also available in 2 single vision customized versions. There is the Zeiss 3D single vision and the Zeiss Individual single vision. The 3D single vision would be customized for prescription, and the Individual single vision would give you the you're able to specify the back vertex distance, the wrap, and the panoscopic tilt. So the Individual single vision would be the very best. 3D single vision would be good entry level and will be much better than a standard single vision lens. One of the things about single vision is that we haven't realized that it is a product that we actually can improve on, and we definitely can improve on it through customization. And so that is another availability that you have in all of the materials that we mentioned before. So I want to thank you for your time, and I hope this was helpful. And Soderbergh has all the information for you, and all the availability of this product is they are able to produce all of this product in-house, excluding the 174, which comes from Germany. But that is ordered through Soderbergh as well. So thank you very much, and I will turn this back over to Mandy.